So a couple things I want you to realize when we are doing algebra. There are certain things that we all understand, even though it's not written. So one of the things that we have to understand is that multiplication is never written. The multiplication symbol is never written. So for example, I have the plus to indicate I'm adding two numbers. However, with multiplication, we don't write it. So here we have 3n. We understand it to be 3 times n. So there's a multiplication in there right between the 3 and the n. We never write it, but we understand it to be there. Please remember that the n represents a number. It is just a number. It could be 2, it could be -5, it could be 10. It's just a number. We just don't know what number it is. So this is 3 times whatever number that n represents. And here's another place, and say the same thing with 6n. There's a multiplication between them. So this is going to be 6 times n. Here's another multiplication. 1 is where this 6n is being multiplied by everything that's in the parentheses. So there's another multiplication there, but we don't write it. Think of it as invisible math. We understand it to be there. So this is 6n times 3n plus 2, everything that's in the parentheses. The other thing that we don't write in, but we understand it to be there, is the exponent to which this variable is raised. This variable is raised to the exponent 1, both of these, but we don't write it. Okay, we understand that exponent to be there is 1. Okay, so if I'm going to multiply this out, that would be 6n times each of these terms. I'm going to be multiplying it out. So it's going to be 6n times 3n, which gives me 18n squared. And then I multiply 6n times 2, positive 2, which gives me plus 12n. Now please remember, when I'm multiplying two variables with the same base, I add their exponents. So n, this is n to the 1 times n to the 1. It's going to be n to the 1 plus 1, which is 2, n squared. Okay, so that's how I end up with n squared. So another way of thinking about it is, let's multiply the numbers. 6 times 3 is 18, and n times n is n squared. Same with here. It's 6 times 2 is 12, and n times nothing, well, 1 is n. All right. Here's another one. And this is a one that many students will get wrong because of the signs. One of the things I want you to remember is if I'm multiplying or dividing two numbers with the same sign, they become positive. So negative numbers times a negative number is going to be a positive number. If they have different signs, one is positive and one is negative, the answer is going to be negative. So -3 times a positive 5 will give me a -15. So in this particular case, again, we are multiplying. We understand there's a multiplication here. We understand there's a multiplication there. It's just not written. So I'm going to and because everything is in parentheses here, I have to multiply everything in the parentheses by -3. So it would be -3 times the 5n would be -15n, and -3 times -1 is going to be +3. Now don't make that mistake, that you forget that negative times negative is positive number. Okay, here's my other example. Suppose I have two things in brackets multiplying, these double brackets. Now one of the things I want you to realize that there are many different ways to multiply this. So I'm going to go through a couple of different ways so that you're not stuck on just using the FOIL method and you can't do it in your head or something. Okay, so one of the ways is the grid method. In the grid method, I draw a grid. I put the n here, this n, and this 3 in each of the columns of the grid. And then I have the n and the -5 along the rows of the grid. And then I'm going to multiply each row and grid. So n times n goes in here, which would be n squared. And n times positive 3 goes in here, which was going to be 3n. And do the other row as well. N times negative 5 gives me negative 5n. Try to give myself more space. And n times, negative 5 times positive 3, negative times positive gives me a negative 15. All right, and then we combine the like terms. There's only one n squared and only one constant, but there's two n terms. There's 3n and negative 5n, so I'm going to add those together. So my final answer is going to be n squared, and when I add the 3n and the negative 5n, I get negative 2n. Negative 2n, and then I have the constant negative 15. So that's my answer. That's one way of doing it. Another way of doing it is I can say n plus 3 multiplied by n minus 5, the column method. So in this particular case, just like regular multiplication, what I'm going to do is multiply negative 5 by everything in here. So negative 5 times positive 3 is going to be negative 15. Oops. And negative 5 times n is going to be negative 5n. And then when I'm doing the next one, n times each of these, I'm going to put them under the column with the like terms, all the terms under each other. So for example, this is going to be n times 3. 3 gives me 3n, which is 3n here, positive 3n. And n times n times n is going to be n squared. And then just like multiplication that we are used to in middle school, I bring down the 15, I add these two, gives me negative 2n, and then I have n squared. Please note, same answer. But then there is also the distribution method as well. All right, so the next one I could do is the FOIL method, or distribution. Let me do the distribution method first. Please note that each of these I'm going to be multiplying n multiplied by everything in here. So I can write that down. It would be n times n minus 5. And then positive 3 times n minus 5, which is plus 3 times n minus 5. And then we have already reviewed how to multiply this out, yes? It's going to be n times n minus n times n is n squared, and n times minus 5 is negative 5n. Then plus 3n, and 3 times negative 5 is negative 15. And then I'm going to combine the like terms, right? Always simplify your work. So it's n squared minus 2n minus 15. Now please note I'm getting the same answer no matter what method I get. They're always the same. So any of these methods are alternatives to the FOIL method. Whatever helps you to get through it, okay, without making mistakes.